Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, Mrs. Lindsay.
Hey, Mr. Bergmann.
Hey, we're learning more about these minerals. Last time we learned about like what minerals are, their cool crystal stuff. But today we're going to learn about the properties of minerals. So tell me more about these simple tests that we do. So the properties of minerals.
Well, geologists need to find out what a mineral is, and what better way to do that than to test
Well,
it?
I guess we're scientists, and scientists do experiments. So that's like, so they're going to do some tests based upon what?
Well, first thing, you should look at their physical and chemical properties.
All right, physical, chemical. What's the difference?
Physical are the properties that can change. They can change in color, different color.
So color, also things like their melting points.
Yes.
Things like that. But chemical properties, now what's that?
Those do not change at all. They're exactly the same throughout the sample.
Okay. All right. And what are some examples of some tests that we could do?
Now, we could look at the crystal form.
Crystal, okay.
Maybe it's cubic, maybe it's...
Oh yeah, we talked about those shapes in the last
Orthorhombic,
video.
right.
Okay. What else?
We can look at its luster.
Luster. That sounds like shiny stuff.
I would think so.
Awesome. What else?
Hardness.
Hardness, okay.
They're not all...
Some are hard and some are soft.
Exactly.
Yeah.
We
Anything
all know
else?
about diamond, right?
Oh yeah, diamond's super hard, right?
Something called cleavage.
Cleavage. So that's the ability to like cut along like planes, right?
Yeah.
Okay.
We have fracture. That's another
Fracture.
example.
Something, they seem, are they different, cleavage and fracture?
They are different, but we make a comparison of them to each other.
Oh, okay. All right.
Streak.
Streak, what's that mean?
Well, it's not running around without your clothes.
Oh, that's good. Some of these words kind of are a little, racy.
Little suggestive,
Cleavage,
yeah.
streak, yeah, etc.
Yeah, we'll find out about streak. It has to do with color, but not exactly.
So tell you what, let's go a little deeper on each of these one at a time. So let's go to the first one, which is crystal form. So let's take a look.
Okay, let's take a look.
So what about crystal form?
Well, crystal form also has the word habit, and it's just looking at its crystalline structure.
Okay. So if we take a look at this one right here, it's got a specific structure. It's got a shape, doesn't it?
It does. It has. This is called a rhombohedral shape.
I can
Notice
see that.
it's leaning.
Yeah, it's a leaning cubey thing.
Yeah,
All right. This one right here is a different shape altogether.
it is. This one's orthorhombic.
Orthorhombic. That's a fancy word. I bet you maybe learned that in geometry class, maybe, huh?
That sounds like geometry.
What about this one? This one's pretty cool. We saw that one a little bit earlier.
Yeah, this one's interesting. It has the crystal shape is not really very apparent,
Yeah.
but it is kind of looks like a flower.
Yeah,
It's
yeah.
growing, but it's chemically the same as this one.
Wait a second. You're telling me these two are the same chemical.
Exactly the same chemically.
So this one formed differently than this one. So that's what makes them different.
It does.
Even
yeah,
though they're made of the exact same chemicals.
exactly.
Weird. Okay. And this one has some really cool structures. We can see right there all the different shapes like sticking out.
Yeah, this is a hexagonal prism.
Oh,
So
okay.
it's got, if you count the sides, it has six
Six-sided
sides.
prisms. Okay. And then we've got this one right here. Pretty squarish.
It does look squarish.
Is it square?
It is square. It's got, if you look at the corner right here, one of those corners, it has 90-degree angles all the way around.
Ah, okay. So that's a cubic structure, right?
Yep.
This one doesn't seem to have much of a structure here.
It doesn't. We actually just say that has sheets.
Sheets. Ah, okay. Does this have sheets too?
This one has sheets too, but it has a different color.
Oh, it's the light-colored sheety guy. Okay. That's pretty cool, the crystal forms. Those crystals are awesome. What about luster?
Well,
So what is luster?
luster is a reflection of light. So maybe you could say shininess.
Okay, so the way a mineral reflects light. Okay, that works for me. So some of it's shininess, okay.
Shininess.
And there's
yeah.
two types of shininesses.
There's metallic
Metallic.
and non-metallic.
Okay, so basically shiny and not shiny.
Shiny and not shiny.
So metallic and non-metallic.
Yes.
All right, so any examples? Ah, there's something shiny.
Gold.
Gold is shiny. Oh, gold. All
We
right.
love gold.
Yes. So non-metallic luster is dull, pearly, waxy, silky, or so basically not shiny.
Not shiny.
All right. Talc is pearly and
Kaolinite. which is
Kaolinite.
which is really
is-
just clay.
Oh, kaolinite is clay. I was thinking it sounded like Superman, like kryptonite.
Yeah,
But
it sounds cool,
kaolinite. But
yeah,
it's not quite as
sadly.
exciting as that.
No,
Okay.
not really. Sorry.
So luster is the second one. All right. And here's some pictures. I like pictures. So metallic luster, earthy luster. Oh, so you said two. There's like three kinds.
There's actually, when you get into the non-metallic lusters, there are so many different kinds. But if you can decide if it's metallic or non-metallic, that's really all you need to know.
Okay. All right. So there's like 10 different lusters, but
Yeah,
the main break is metallic, and then the non-metallic, there's 7 or 8 of them or something.
exactly.
Okay. All right. I didn't know that. That's cool. All right. So let's take a look at a non-metallic luster, non-shiny mineral.
Okay.
All right. We got some different minerals here. All right.
A couple
Shiny.
was
I found a shiny one.
Looks like a metal.
So that would be like lustrous. No, metallic.
That would be metallic luster, yeah.
Okay. And this one?
This one is
Not shiny. But it's
it's
kind of cool.
deceptive. It's got some shininess, but
Yeah.
it doesn't look like a metal.
So it's not metallic shiny, but it's shiny.
Yeah.
So it's not metallic.
Right.
So it's metallic versus not metallic. So
Right.
shiny, but not metallic.
Exactly.
And these ones over here,
And these are both non-metallic. Again, this one is, if you look at it just right, it's a little tiny bit shiny.
yeah.
Sometimes it catches the light, but then this one,
Not at all.
that's
It's just dull.
Yeah,
Okay.
very dull.
So that's luster. That was cool. Well, this next one is called how hard it is, or hardness.
It is
So
hard.
let's talk about that one, right? Hardness is the measure of how easily a mineral can be scratched by certain substances. So we're like going to scratch minerals with other minerals?
With other minerals, with our fingernails, with
Our
nails.
fingernails, I'm going to break my fingernail.
Oh, well, it'll be okay.
Oh, well, okay, all right.
Don't push too hard.
All right, so there's this cat named Friedrich, somebody.
Look
He
like
developed Friedrich Moss. I think it's Friedrich.
it is.
And he created something called this scale thing, right? And so
Yeah.
what is that? Oh, we have a cool diagram. Look at that.
So yeah, it's a scale of the softest to the hardest.
All right, so
No.
talc is 1 and diamond is 10. Now what's talc?
Talc is basically, well, it's an ingredient that's in powder.
It's in powder. It's like talcum powder, right?
Mm-hmm.
And like chalk, what's chalk? Is it kind of in that one range? So chalk is
Chalk is pretty close. It's about 1 to 1.5.
so think
very
think of a
soft.
piece of chalk, right, from school. Well, a lot of schools don't have chalk anymore.
That's
But chalk is kind of down here, and a diamond is super crazy hard.
Super crazy hard.
And then there's everything in between. So a scale of 1 to 10. So am I right that if I have a 10, it can scratch a 9?
Yes.
And a 10 can scratch a 2.
Yes.
But a 2 can't scratch a 3.
No.
You just scratch the other one. All right. So you've probably seen that in the movies. The diamonds can scratch anything. So, in fact, one thing that diamonds are used for is industrially is because they are so hard. They are used for drill bits and lots of other interesting things, other reasons too, because of super high melting point too and stuff. But its hardness means it doesn't get broken
Very
because
hard,
nothing
yes.
can break a diamond except another diamond.
Another diamond.
Makes sense.
So if we go back to our real pretty fluorite, our green fluorite, an example, it looks like it's really hard. And I would think it's really hard. But if I try to scratch it on the glass,
You can't scratch the glass.
no, I can't scratch the glass. The fluorite actually got
Scratched by
turned in, right, it got scratched.
Okay.
So if I take, so this piece, remember this piece,
Yeah,
this is quartz.
Yeah.
Well, quartz, if I put it on the glass,
You just scratched the glass.
I did.
So quartz is harder than glass.
Absolutely. And
Right.
quartz is harder than fluorite.
Yeah. Okay. So it's like a test. You scratch things with each other, and you figure out who's what, and it helps you determine which is which.
Exactly.
Awesome. Well, that was really fascinating. This next one sounds kind of like racy, but it's called cleavage. So cleavage is what?
Cleavage is if a mineral breaks on certain lines.
So it
So-
breaks on certain lines. So if I've
At
got
certain angles, yes.
a mineral, let's say, it's maybe a structure like this, there might be a place where I could cut it and it will break right down the center.
Exactly.
Or to the side, along actually certain, it has to do with the crystal structure on the inside and how the atomic bonds hold it together. So they break along planes
Yes.
where atomic bonding is weak. All right. If you remember back to chemistry land, folks, this is actually usually, it almost always breaks along the, you remember the LDFs, the London dispersion forces. That's where if you've got a mineral, like a classic example is graphite. I'm going to attempt to draw graphite. It's this hexagonal structure, okay? And the bond inside here is crazy strong, but the bonds between are super light. And when they're super light, it's easy to fracture it along the London dispersion forces because that's a weak bond in between.
Is that what makes you write with it?
Yes, that's why when you're writing with a pencil, graphite pencil, that's why it breaks along those fracture lines and it sticks it on the table, or on the paper rather. All right, a mineral that splits relatively easily and is said to have cleavage. So if it splits really easily and makes a nice, pretty cut.
Flat side, yeah.
Flat side, okay, flat planes, there we go. That's said to have cleavage. But that's a little different than something else, right?
It is.
Well, actually, let's take a look, right? You could take a knife and you can see, if you look carefully here, how you could cut. This is, I think, mica. And you can cut it nice, super clean sheets. That's actually opaque. I can see through it because it's so thin they cut it. And the knife blade cuts it through. And it's kind of hard to see. You get the weak bonds. Oh, that's a picture I just drew, actually, isn't it? Pretty much. That's a cool picture, by the way. All right. Oh, some more cleavage lines. All right. Cleavage in one direction. All right. Cleavage here at different angles. Oh, at 90-degree angles for this thing called muscovite. No, that's not muscovite. This is muscovite. This is halite. Halite salt.
Salt.
Yeah, yeah. And then other directions, this is calcite, and it's not quite 90 degrees. We have different degrees, 75. So it's at different angles.
Exactly.
It has to do with the
Kinda
crystal structure, folks. Because even though they might have, I don't know, go too much details, but it also has to do with the size of the atoms. If you've got big atoms and small atoms, and the way they stack together determines how they're going to cleave. That's what it wouldn't cleave there because it would go between an atom. That's not going to work. But that makes a difference in terms of getting these interesting shapes and structures. All right, fracture. What's fracture?
Fracture sounds
Like breaking
like
an arm.
breaking,
I
exactly.
fractured myself one time.
I bet that would hurt.
Yeah, it's not any fun to fracture. I bet you fractured. A few of you, right? Minerals that break with rough or jagged edges. Oh, so it's not like a clean break. It's a jagged break.
Yeah, nothing flat. It's gonna have pokey edges, and it's not gonna be pretty.
So quartz apparently is an example because it has uneven, jagged,
Yes,
right? Okay.
Absolutely.
Flint, jasper. All right.
Chalcedony. I guess chalcedony.
Chalcedony. Sounds like something from Downton Abbey.
It does.
Chalcedony. All right. Fracture with arc-like patterns. I bet we need a picture to understand this. Oh, here we go.
Absolutely.
So that's an irregular fracture. Okay. We've all probably seen locks. That's quartz, I think, isn't it?
It is quartz.
See, I can remember something.
Very jagged.
And I can see that. That's cool how it's got that shape that's like a cone.
It's like it's like a shell. It's
A
like
shell.
a curve.
But
You
it's
might have-
not it's not a fossil with shells in it. It just broke in a conical fracture deal, right?
Right. Exactly.
Ah.
Almost like when you get those on your windshield sometimes from rocks.
Oh, wait. So are you saying something that glass is a mineral?
Glass is a mineral.
And it breaks like a conchoidal fracture?
Conchoidal fracture.
Conchoidal
yeah.
fracture? Yeah, she
Conchoidal
knows how to say
fracture.
these words, folks. You can tell who's the smarter person here.
Now you got to practice.
Oh, got to practice. Conchoidal. Say it again?
Conchoidal.
Conchoidal. I'm going to get this by the time I see you in class. Okay. And what's the difference between, are we going to look at some, what are we going to do here?
Yeah, we're going to make a comparison of some minerals that have some cleavage and some that have some fracture.
Oh, awesome. All right, let's do that.
We'll go back to some of our minerals that we looked at. So we have this mineral, and when you want to look at cleavage, you need to look inside.
So I see kind of like a line in there.
Right, and do you notice how that line matches the top and bottom
Yeah, it's like
planes?
the same plane, yeah.
Exactly. So that's where it's going to break. If I smash this, which I won't, it would actually break on that line.
Nice, cool.
So,
All right.
and that's an easy one to see. Here we have with our sheety guys.
So, oh yeah, you can like
See,
just
they
take your
just
fingernail and
peel
peel it
apart,
off, and that's
right.
really a cool mineral. Yeah, that's
And
awesome.
that's another flat plane. And then we have, so those are cleavage.
Right?
And then fracture, here's that conchoidal fracture we talked about.
Yeah, I see that.
So nice
And
curve.
is this one fractured too?
That is fracture as well. It's nothing, I don't know.
It's not very pretty, but it's a boring looking mineral. But hey,
It's
okay.
jagged.
It's jagged.
It's
and
fractured.
It's fractured. There you go.
That's all you
right.
need to know.
So fractures and cleavage. We got it.
You got it.
Well, I think we've learned a lot in this lesson, and next time we're going to learn about the other properties of minerals. They've got lots of cool properties.
They do, absolutely. And there are a lot of them.
Awesome.
But that makes it easier to identify once you can know their properties.
Then we can figure out which mineral is which and which one is the other and stuff.
Exactly.
We'll see you in class.